Yes. Look at all those particles just shooting off the Americium source. Every single one of those streaks represents an atom that just decayed. That means every path you see is an actual alpha particle emitted in real time from a single atom of Americium transforming into another element. Look how they're just constantly pouring off this source. It's like it never runs out. That's because Americium-241 has a half-life of about 432 years. That means it takes more than 4 centuries for just half of the atoms in this tiny button to decay. So if there's one big takeaway from this, it's to remember that there's lots of atoms in things. The atoms are constantly pouring off of this, but it never runs out. Okay, now that our cloud chamber's working, let's try putting some thin, solid gold in front of it. Now this part was actually harder than I expected. Gold foil is very thin and it rips really easily. I went through a lot of gold sheets before I finally got a setup that worked. To make sure we get an accurate test, I placed the gold foil completely against the floor of the chamber, so there's no way for alpha particles to sneak underneath it. Okay, let's turn off the lights and see if we can spot the alpha particles going through the gold. Whoa, look at that, you can see it. The alpha particle paths are going right through the gold. So just like in my vacuum chamber experiment with the particle detector, this shows that most of the space in an atom is empty. And what I mean by that is 99.4% of the mass of these gold atoms is concentrated at a single point in the center called the nucleus. And what that means is that almost all of the atom is completely empty space. But it's not empty. Most alpha particles fly straight through the atom, knocking off any electrons that get in the way. But every once in a while, an alpha particle gets a direct hit on the nucleus. When that happens, the alpha particle can get deflected or even bounce back. The ability for gold foil to send an alpha particle bouncing backward was the first proof ever that atoms contained a nucleus. So now let's look behind the gold sheet. Can we see any alpha particles moving backward toward the source? Look, every once in a while you see a streak coming from the gold back toward the source. That could be an alpha particle that hit a nucleus and bounced back. So having these alpha particles bounce back like this is actually pretty amazing. In Rutherford's gold foil experiment, when he saw evidence that the alpha particles were bouncing back off the gold, he said it was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. This experiment is so cool. It proves something incredible. The nucleus is real. Atoms aren't blobs of charge like the plum pudding model suggested. Instead, they're mostly empty space with an ultra-dense, positively charged nucleus at the center. And when an alpha particle collides with one of these nuclei, it scatters, sometimes even bouncing straight back toward the source. This couldn't happen unless there was a nucleus. This was one of the most important discoveries in physics, and it completely changed our understanding of matter. I love this experiment because it takes something that was originally just a mathematical conclusion, something scientists had to infer, and it lets us actually see it with our own eyes. And all it takes is a bit of gold foil, a radioactive source, and a cloud chamber to recreate one of the greatest breakthroughs in science.